Welcome back for the last video of Module 7. This is going to be Lesson 8, Part 2, where now we're going to start taking word problems and converting them into two-step equations, or inequalities, and then solving them. First problem we have says that halfway through the bowling league season, Stewart has 34 strikes. He averages 2 strikes per game, and he needs at least 61 strikes in order to beat the league record. Write and solve an inequality to determine the possible number of additional games students should bowl to have at least 61 strikes. So let's get into it. First thing we need to do is come up with some words to talk about this. And looking at that problem in words, it's going to say something along the lines of the number of strikes Stewart has plus 2 more strikes per game, because that's his average, needs to be at least, that means greater than or equal to, the total number of strikes needed. From there, defining your variable, they let G represent the number of games that he's going to have to play to get there. And from there, we have an inequality that says 34, that's the number of strikes he already has, plus 2 times some number of games is greater than or equal to the 61 that he has for his goal. Moving forward with that, we've got our inequality set up, and you can see from there, they worked it just like all the other inequalities we've been doing today. They undid addition and subtraction first, subtracting the 34 from both sides, leaving themselves with 2g is greater than or equal to 27. Then they undid multiplication and division, dividing 2 on both sides, and that left them as g is greater than or equal to 13.5. So that means that he needs greater than or equal to 13.5 games, so at 13 and a half games, hopefully he'll have the strikes he needs. Is it going to give me credit for this? It is indeed. My thought on that, I'm thinking he probably has to play the 14 full games in order to get it. When we graph it on the number line, we're going to go at 13.5. It's going to be a greater than or equal to. So here's my 13.5. My line goes to the right. Let her go and check. That is showing your work, folks. That is what we must see for these. And once again, it is your turn to work the next problem, extra example number 4. Read through it, solve the problem, and I believe you have to come up with your equation, come up with the solution, and interpret what the solution means. Get started on it, okay? Our friend Tim here has already earned $40 mowing lawn. So that is going to be Tim's starting point. Let's see if I can get it to work. Alright, so we're going to start off with $40. And he earns another $10 for every lawn he mows. So that can be plus $10 times some number of lawns, I got a lowercase l there, is equal to, and they want us to find out how much he needs to get at least, so it's not going to be equal to, it's going to be greater than or equal to $95 as a target. So that's the formula we're going to work with at first. Let's find one here that looks like that. 40 plus 10x, nope, that's less than 40x, nope, that's going to be D. D is going to be our formula. And then we're going to isolate the variable, subtracting 40 from both sides on the left and on the right. When I do that, these zero out, leaving 10 times the number of lawns has to be greater than or equal to 95 minus 40. That's going to leave me with 55. From there, we're going to isolate the variable, divide both sides by 10. 10 divided by 10 is 1. 1 times the lawns is going to be greater than or equal to, and that's going to give him 5.5 lawns. Now, do you really think they're going to pay Timmy for only cutting half a lawn? I don't think so. My thought on that is he's going to have to mow greater than or equal to 6 lawns. And let's see what we have here. Sure enough, same thing I'm thinking. 5 lawns isn't going to be enough. 5.5 lawns, he doesn't get paid for a job half done. He has to cut 6 whole lawns in order to make the money he wants. In example 5, we have Meredith, and she was given a $50 monthly allowance to buy lunch at school. Any remaining money can be spent on entertainment. I think I'd starve to death if I was a kid getting $50 a month to eat, because I'd be saving that for other things. Let's see, Meredith would like to have at least $12 left at the end of the month to go to movies with her friends. It costs Meredith $2.50 per lunch that she buys at school, and they want us to write and solve an inequality. Well, we know that we've got $50 as our starting point. And we know that every time she buys a lunch, she has to subtract $2.50 from that. So I would set up something that says the $50 minus $2.50 times some number of lunches, and we still want that value to be greater than or equal to the 12 right there. Let's see what they say. Probably pretty much the same thing I just said. In words, we've got the monthly allowance minus the cost per lunch is at least the remaining amount. So in variables, where they decide to let x equal the number of lunches, and then the inequality is going to be exactly what I said, 50 minus $2.50 times some number of lunches is greater than or equal to 12. From there, it's solved the problem just like all the other problems we've done in this lesson. They undid addition and subtraction, subtracting 50 from both sides. The 50s on the left zeroed each other out, leaving $2.50 times x is greater than or equal to 12 minus 50. That gave them a negative 38. But there's going to be a catch in this one. See that big old, whoop, went too far there. See that big old blue alligator that changed directions? He changed directions because they divided both sides by a negative 250. And when you divide both sides by a negative number, that alligator is going to turn around and bite what's behind it. That means that your final answer, x is going to be less than or equal to 15.2. So once again, can she really have 15.2 lunches? No, I think a real world application on that would mean that she can actually only buy 15 lunches. Graphing that, we're going to go down to the 15.2. It is an or equal to. So we're going to have the 15.2s here, so she can buy 15.2 or less lunches. Check the answer, and the answer checks. And now it's time for you to work your final extra practice problem. That's extra practice number 5. Pause the video and do this, please. Violet, I thought that was a color or a flower or something like that. Anyhow, person this time. Violet received $25 gift card into a hot chocolate shop. Didn't know they had shops dedicated to just hot chocolate. Her favorite drink cost $3.20 per cup. She wants to leave at least $5 on her card to buy herself a new mug. So we have to come up with an inequality to represent this. First off, she is going to be starting with $25. That's where she began. From there, we're subtracting $3.20 every time she buys a cup of hot cocoa. I'm using C to represent cup. And she wants that final amount to be at least, and at least means greater than or equal to $5. So that's the inequality I came up with. Let's see what I can match it with here. That's going to be, right there. Answer's A, right on top. Now we need to take and solve the question to find out the rest of the information. Now I'm going to undo addition and subtraction by subtracting that 25 from both sides. I subtract 25 on the left. I'm going to subtract 25 on the right. Problem is, I've got a negative $3.20 left times the number of cups on the left, but on the right, I've got a signs for different, find the difference issue. The difference between 5 and 25, that's going to be 20, with a sign in front of your larger number, negative, going in front of your answer. Now we're going to undo multiplication and division by dividing by $3.20. Negative $3.20 on both sides. Now when we do that, very important, that sign is going to change directions. It changed directions because I divided both sides by the same negative number. The negative signs on both sides are going to divide out. The 320s are going to become 1. 1 times C is C. And then over here, I need to take $20, divide it by, I'm just going to call it 3.2. No reason for the extra decimal to be there. Bounce the decimal outside the house until it hits the wall. Bounce the decimal inside the house, the same number of spaces to the right. Annex in zeros as needed and move your decimal up. 32 goes into 2, nope. 20, nope. It does go into 280, and I'm going to take and say 6. Let's try 6. 6 times 2 is going to become 12. 6 times 3 is going to be 18, plus 1 is going to be 19. That did work with a whopping 8 left over. We're going to annex in a 0 and bring it down. 32 is going to go into that 64 times. And when I subtract that out, I'm going to have to do some borrowing here. That's going to give me a 16. 32 is going to go into 160. How many times? I'm going to say 5 times. 5 times 2 is 10. 5 times 3 is 15. Plus 1 is 16. So my answer is C, is less than or equal to 6 1/4 cups of coffee. Jump back over to the problem here. It can be less than or equal to 6.25. That checks. And the final thing I have to ask myself, can she really buy a 1/4 cup of coffee? No, she cannot. So she has to have no more than 6 cups of coffee if she wants to be able to buy that fancy mug of hers. That is it for this lesson. Get busy working on your homework. Give me good, high-quality supporting work so I can give you credit for doing it.